state-of-the-art technologies, innovative business strategies, behind the scenes, insights from cutting-edge users around the globe on World Business Review.
Welcome to World Business Review. I'm Norman Schwarzkopf. Electro-optical and armor technology currently being used by military personnel is heavy and scratch-prone, making visibility and logistics the support difficult. A new ceramic armor technology is offering improved performance and protection. Dr. Larry Fehrenbacher, President of Technology Assessment and Transfer, is here to discuss this vital technology. Welcome to World Business Review, Larry.
Thank you very much. I'm honored and privileged to have this opportunity to discuss our technology, General.
Also joining us today is our in-studio correspondent, Jordan Goodman. It's a pleasure to have you with us, always.
Nice to be with you, General.
Larry, tell our viewers what the chief concern is regarding current technology.
Well, current windows and domes used on missile seekers and reconnaissance pods either cut off too early in the infrared region, or they suffer blindness at high aerodynamic speeds, and they're very, very prone to erosion from sand and rain. So with these new emerging systems, you need better materials with better performance in the mid-IR and better resistance to rain and sand erosion.
How is your technology providing a solution to the military that they haven't had before?
Well, our technology is based on a material known as Spinel. Spinel is a ceramic material that has a very, very wide transmission window. It is very, very hard and therefore very, very durable. Therefore, it provides better image quality, better target acquisition distance, and better scratch resistance and better resistance to sand and rain erosion, which is a big logistics fail. For armor, because of its hardness, you can achieve the same ballistic protection at half the weight and half the thickness of glass armor that's currently being used.
For more, let's go to this World Business Review field report.
Transparent ceramic products demonstrating exceptional performance properties for missile domes, reconnaissance pods, laser communication, and armor are all crucial to ensuring the safety of our armed forces worldwide.
Optically, Spinel windows, lenses, and domes offer much better image quality over a wider frequency range and at a higher temperature. So this, of course, improves target acquisition and weapon delivery capabilities.
Glass armor currently used is heavy and scratch-prone, making transportation difficult. It also has a large damage zone, making visibility near impossible once it has been hit.
Compared with the current products in the field for military applications, our transparent Spinel has demonstrated equivalent protection at half the thickness. So we're talking the same threat, the same velocity, we can stop at half the thickness. This means a large reduction in weight, and it means improved visibility for the soldier.
Spinel domes and windows offer better image quality over wider broadband at a higher temperature, thereby increasing target acquisition and weapon delivery capabilities.
Transparent Spinel is actually applicable to a wide range of military applications because in addition to its improved optical properties, it has a very high resistance to wear and corrosion, and it can be used in higher temperature environments. Spinel is actually thermodynamically stable. You can find it occurring naturally. We're not trying to force any atoms into lattice sites where they don't want to be. We're just helping them along a little bit.
For World Business Review, I'm Jamie Mahler reporting.
Larry, what was the motivation for founding Technology Assessment and Transfer?
Actually, it started really as sort of an accident. I'd spent 20 years as an active Air Force R&D officer, and when I was nearing retirement, a couple of Fortune 500 companies came to me and asked if I would be interested in consulting and helping them sell their R&D capabilities to the military. Well, after about 3 years of being quite successful at doing that, Congress passed the Small Business Research Innovation Initiative, which turns out to be a tremendous growth engine. What that legislation did, it was set aside a certain percentage of R&D funds from each federal agency strictly for small business research. It was at that time I decided to try and see if we could develop our own research and development capabilities. So I wrote an SBR proposal. Fortunately, I happened to win that Phase 1 award, and thanks to the use of facilities at the National Bureau of Standards as a guest researcher, we we were able to complete that program successfully, and that's exactly how we got started.
What were some of the early obstacles in creating this technology?
Well, money, of course, and we had no outside financial backing, so we really had to build up revenues through growth of consulting, our SBR contracts, and the use of outside facilities. And after a few years, we were able to start buying equipment, used equipment, for 10 cents on the dollar. We rented lab space, and now we've currently grown into 16,000 square feet of facilities in 2 different locations.
Where's the technology currently being used?
Well, it's currently being used on an acquisition tracking pod that's being installed in the F-15 and F-16 aircraft. It's also being installed in non-civilian vehicles for increased armor protection. And of course, it's being evaluated in several applications, including the small diameter bomb, the Joint Common Missile, targeting pod for the F-14 and the F-18. It's also being looked at as a possible window for combined laser and RF communication systems.
What is the driving force behind transparent Spinel ceramic technology?
Well, the driving force, of course, is the increased performance and durability that you can achieve with the use of this hard ceramic transparent material. As a result of that, that's why it's a prime candidate for the systems that I just mentioned, such as small diameter bomb, Joint Common Missile, and of course armor.
How does what this does technology compare to what the military is currently using?
Well, because, as I mentioned earlier, because of its wide optical window, its extreme hardness, and its extreme transparency at very high aerodynamic speeds, it is a much better candidate than the current window materials. The current window materials are going, if they were going to be used on these future systems, they would impose almost an unbearable logistics cost burden on the military.
How can insertion into military systems be accelerated? You've got this great technology. How can it get out in the field faster?
Well, that's a good question, and of course that depends on funding. And now continued out your funding for programs like the Joint Common Missile and small diameter bomb. In fact, if that funding does come to fruition, they will probably start initial low-rate production, as is known in the military, in about 2 to 3 years. For armor, of course, the escalating threats are driving the need for increased insertion of Spinel and hard ceramic armor. Hopefully, funding for the Army's what the Army calls the long-term armor solution, which they hope to outfit all the tactical vehicles in the field with better armor, will come to fruition as well.
Well, thank you for a most enlightening discussion. I'm happy to hear that progress is being made out there for the good of our tankers, and they need a lot of help. And thank you always for being here, Jordan. It's great to have you.
Thank you very much, General. Appreciate it.
Well, thank both of you for inviting me. I really appreciated this opportunity.
And thank you for watching. Until next time, for World Business Review, I'm Norman Schwarzkopf.